Today's topic is Splay tree. Splay tree is a self-adjusted binary search tree in which every operation on element rearranges the tree so that the recently accessed element is placed at the root position of the tree. Okay, so we can say that this split tree is a balancing binary search tree with the additional property that recently accessed element are quick to access again because it is placed at the root position. Okay, in a split tree, every operation is performed at the root of the tree. All the operation in a split tree are involved with a common operation called splaying. Okay, so splaying means splaying an element is the process of bringing it to the root position by performing suitable rotation operations. Okay, so this split tree is like a binary search tree. Uh, as all of you know about binary search tree, in a binary search tree, uh, the element which is less than root node, we place that element in the left subtree of the root node. If the element is greater than root node, then we place that element at the right subtree of the root node. Okay, so like binary search tree, we can perform different operation with split tree, like insertion, deletion, remove, insertion, deletion, search operation. Okay, so but the difference between binary search operation and split tree operation is that with every operation on a split tree performs the splaying operation. Okay, now we consider the case of insertion operation. Here, first insert the new element using binary search tree insertion process. Then the newly inserted element is split so that it is placed at the root of the tree. Okay, it means if we consider the case of binary search tree, if we want to insert element, okay, now we check, we compare that element with the root element. If the element which we want to insert is greater than root element, then we insert that in a right subtree. Okay, here we perform the same case, that is we insert element, but we have to perform one additional step, that is splaying. Okay, so that recently inserted element we have to place at the root position. Okay, second operation, suppose we consider the case of a search operation. The search operation in a split tree is nothing but searching the element using binary search process and then splaying that search element so that it is placed at the root of the tree. Okay, so to perform this splaying, we have to consider different cases of splaying. Okay, so here we consider three main cases. Okay, that is zig rotation. Second case is zig rotation. Third case is zigzag rotation. Okay, so here we consider zig means right rotation, zag means left rotation. Okay, if we refer different documents, in some documents it refers zig for left rotation and zag for right rotation or vice versa. Okay, here we consider zig for right rotation and zag for left rotation. Okay, second case is zig. Okay, uh, it means right rotation. Okay, we'll see one by one. So first is zig rotation. Okay, it means right rotation. Here we have to search element 3. Okay, so searching element 3, so we compare 3 with root node. Okay, root node is 5. Okay, so 3 is less than 5, so we go for the left part of that root node. Okay, so we'll get 3 here. Okay, so here we have to perform zig rotation. Okay, it means right rotation. So 3 placed at the root node. Okay, then 5 move here. Okay, so it means 3, this 3 plus at the 5 at the root node position. Okay, and 5 is placed at the right child of node 3. Okay, this is simply zig rotation, that is right rotation. Okay, here this node 3 is the left child of node 5. Okay, it means this 3 is left child of root node. Okay, that is the zig step or zig rotation, we can say. Now second case is Zag rotation. Okay, it means the element which we want to access is right child of root node. Okay, here we have to access element 5, which is the right child of root node 3. Okay, so it perform left rotation, that is nothing but Zag rotation. Okay, so this 5 again placed at the root node position. Okay, 5, then this 3 is the left is so this 3 is placed at the left child of node 5. Okay, so now this node 5 is having left child, that is node 4. Okay, but here left child of this node 5 is 3. Okay, so we place this node 4 as a right child of node 3. Okay, this 4 as a right child of node 3, but on the left hand side of node 5. Okay, this is nothing but Zag rotation. Okay, so Zig rotation or Zag rotation, when we this operation we perform when the accessed element is right or left child of root node. Okay, now second case is Zig-Zag notation. So basically this operation is performed when the element which we want to access is the left child of its child of parent node, and that parent is a left child of its root node. Okay, consider the case Zig-Zag. It means the element which we want to access is the left child of its parent, and that parent is left child of root node. Okay, here we consider the case node 2. 2 is left child of its parent, that is 3, and 3 is left child of root node 5. Okay, so here we have to perform Zig-Zag operation. It means double right operation. Okay, right and then right. Okay, in that case we first perform right operation on parent node, right operation on grandparent node, and then right operation on parent node. Okay, it means in the first case we first rotate this 5 to right side, then we rotate this 3 to right hand side. So after after Zig-Zag operation, split trees look like this. Okay, now the case is Zig-Zag rotation. Here the element which we want to access is right child of its parent, and that parent is a right child of root node. Okay, that is the case of Zig-Zag rotation. Okay, so here first we have to perform left operation on grandparent node, and then left operation on parent node. Okay, so this is the final split tree. Okay, after Zig-Zag rotation. Okay, so in a Zig-Zag or Zig-Zag rotation, first we perform rotation operation on grandparent, then we perform rotation operation on parent. Okay, now this is the next case, Zig-Zag rotation or Zig-Zag rotation. Okay, so here suppose we want to perform Splay operation on node 5. Okay, so this node 4 is left child of its parent, and that parent is a right child of root node. Okay, so this is Zig-Zag case. Okay, it means this node is a left child of its parent, and this parent is a right child of root node. Okay, in that case we have to perform Zig-Zag rotation. So here we perform Zig rotation on its parents. So we perform Zig rotation. It means here we perform rotation on node 5. Okay, so 5 we so this 4 is placed at this position. Okay, node 5, that is the right child of node 4. Okay, this 6 node is the right child of node 5. Then we perform Zag rotation. Okay, in Zag rotation, so that this 4 placed at the root position. Okay, so this 4, here we perform Zag operation. Okay, that is left rotation of this grandparent. So 3 plus as the left child of node 4. Okay, and this 5 and 5 is the right child of node 4, and 6 is the right child of node 5. Okay, so here we perform Zig rotation at node 5 and Zag rotation at node 3. Okay, if we consider the previous case, that is same operation, Zig-Zag or Zag-Zag, first we perform that operation on grandparent, then we perform that operation on parent. Here we consider the case of Zig-Zag. Here we perform first rotation, that is Zig rotation on parent, then Zag rotation on grandparent. Okay, now this is the second case, Zag-Zig rotation. Here we have to Splay node 4. Okay, this node 4 is right child of its parent node 3, and this parent node is left child of root node. Okay, it means this is the case of Zag-Zig rotation. So here we perform Zag rotation on its parent. Okay, and then we perform Zig rotation on its grandparent. Okay, so this is the result of Zag rotation, and this is the result of Zig rotation. Okay, so this is all about different rotation in Splay tree. Now we'll see how to perform insertion operation. So to perform insertion operation, we have to perform these steps. Step 1 is first we have to check whether that tree is empty or not. If tree is empty, then we insert that new node as a root node and we exit from the operation. Okay, now next step is if that tree is not empty, okay, and then we have to insert that element using binary search tree insertion logic. Okay, then next step is we have to perform Splay operation. Okay, we'll see one example. Okay, here we have to insert node 0, 2, 1, 6, 4 and 5. Okay, so first step, tree is empty, so we insert element node 0. Okay, and this is the root node. Okay, now next we have to insert node 2. Okay, so if we consider this tree, node 2 is greater than 0, so insert node 2 as a right child of node 0. Okay, we perform here insertion operator. Now recently accessed element, it means we recently inserted element 2, we have to place that node at the root position. Okay, so this 2 is a right child of root node. Okay, so it means here we have to perform Zag step, that is Zag rotation. So 2 is placed at the root position and 0 becomes the left child of node 2. Okay, now next step is here we have to insert node 1. Okay, so if you consider this tree, okay, so node 1 is less than 2. Okay, and this node 1 is greater than 0. Okay, so we insert node 1 as a right child of node 0. Okay, so recently accessed node is node 1. Okay, which is the right child of this node. Okay, and this node is a left child of grandparent. Okay, it means node 0 is a parent and node 2 is a grandparent. Okay, it means here we have to perform Zig-Zag. Here we have to perform Zig-Zag rotation. Okay, it means here first we have to move parent. Okay, this is the, here we have to move this parent. Okay, so 0, we place 1 at the 0th position and we pull this 0, node 0. Okay, then we have to perform right rotation. Okay, here first we perform Zag rotation, then here we have to perform Zig rotation. Okay, so this 1 becomes the root node and 2 becomes the right child of node 1. Okay, now next here we have to insert node 6. Okay, so if we consider this node, 6 is greater than 1, again 6 is greater than 2, so insert 6 as a right child of node 2. Okay, so right child of this node, so again we have to perform Splay. Okay, this 6 is a right child of parent node and this parent is a right child of root node. Okay, so this is the case of Zag-Zag rotation. Okay, So it means first we have to perform Zag rotation on grandparent, then we perform Zag rotation on parent. Okay, so first Zag rotation on grandparent. Okay, so this 2 becomes root node. Okay, 1 is the left child of this node. Okay, and again we perform Zag rotation on this node 1. Okay, so when we perform this Zag rotation, 6 becomes root node. Okay, then 2 is its left child, 1 is the left child of node 2, and 0 is the left child of node 1. Okay, now next case is, here we have to insert node 4. So 4 is less than 6 but greater than 2, so we add node 2 as a right child of node 2, node 4 as a right child of node 2. Okay, so inserted this node here. Now we have to perform a splaying operation. Okay, so here we have to perform zigzag rotation. Okay, so we move this parent node 2. Okay, so for this node 4 becomes the parent placed at this position 4, and this previous parent node becomes a left child of this node. Okay, now we have to perform right rotation. Okay, then this 4 becomes root node. Okay, and 6 becomes right child of that node. Okay, now next is, here we have to insert node 5. Okay, so if we consider previous tree, okay, so node 5 is greater than 4 but less than 6, so insert 5 as a left child of node 6. Okay, left child of node 6. Okay, again we have to perform splaying operation. Okay, so first we perform Zag rotation on this parent node. Okay, then uh, after performing this Zag rotation, this is the tree, and then we perform Zig rotation, and this becomes the final tree, final split tree. Okay, so this is all about insertion operation on a split tree. Okay, thank you. This is the figure references.